Welcome to EMR Physics. I am Raju, NCERT 12th Physics. We are solving the numerical problems one by one given in Chapter 4 Moving Charges and Magnetism. In this video, we are going to see how to solve the problem 4.6. The problem is a 3.0 cm wire carrying a current of 10 ampere is placed inside a solenoid perpendicular to its axis. The magnetic field inside the solenoid is given to be 0.27 Tesla. What is the magnetic force on the wire? Now let us see what are the numerical data given in this problem. Length of the wire is given, which is 3.0 cm. Current passing through the wire is 10 ampere. The wire is placed perpendicular to the axis of the solenoid, which means that the wire is placed perpendicular to the magnetic field produced by the solenoid. Since it is placed perpendicular, the angle between the wire and the magnetic field is 90 degree. It is also given that magnetic field is 0.27 Tesla. What is asked? We have to find the magnetic force experienced by the wire. Now first let us write what are the numerical data given. Length of the wire is given. Let us take the length of the wire is L. L is equal to 3 cm. It has to be converted to SI unit meter. Therefore, this is equal to 3 into 10 to the power minus 2 meter. Current passing through the wire is given, which is I. I is equal to 10 ampere. Next, the strength of the magnetic field B is given. B is equal to 0.27 Tesla. This is the axis of the solenoid and it is also the direction of the magnetic field. The current carrying conductor is placed perpendicular to the axis of the solenoid. So this is the direction of the magnetic field. This is the direction of the current carrying conductor or current carrying wire. Since they are perpendicular to each other, the angle theta is equal to 90 degree. Wire is placed perpendicular to the axis of the solenoid, which means that it is placed perpendicular to the direction of the magnetic field. Therefore, theta is equal to 90 degree. What is asked? We have to find the magnetic force F. So, the formula what we are going to use is magnetic force F is given by the relation B I L sin theta. So this is the magnitude of the magnetic force experienced by the current carrying wire in a magnetic field. Here B is the magnetic field, I is the current, L is the length and theta is the angle between the current carrying wire and the magnetic field. We know the value of B, I, L, theta. Therefore we can find the value of F. Let us substitute all the values. B is 0.27, I is 10 ampere, L is 3 into 10 to the power minus 2, sin theta is 90 degree. This is equal to 0.27 into 3. Let us write the numericals first. Into 10 to the power 1 into 10 to the power minus 2 will give you 10 to the power minus 1 into sin 90 is 1. If you calculate, we will get this is equal to 8.1 into 10 to the power minus 2. If we calculate, we will get this value 8.1 into 10 to the power minus 2. This is the value of the magnetic force on the wire. So F is equal to 8.1 into 10 to the power minus 2. Unit of magnetic force is Newton. So this is the magnitude. This is the magnitude. We know that force is a vector quantity. It has both magnitude and direction. Direction of the magnetic force can be determined using Fleming's left hand rule. So what is Fleming's left hand rule? First we have to stretch the thumb, forefinger, middle finger in such a way that they are perpendicular to each other. The forefinger represents the direction of the field Middle finger represents the direction of current. Thumb will give the direction of the force. So according to this rule, if forefinger represents the direction of magnetic field and middle finger represents the direction of current, then thumb will represent the direction of the magnetic force. So this is the answer for the given problem. If this video is useful, please share and subscribe. Thank you for watching this video.